Hello dear friends, welcome to another video of the Never Do Through the GUI What You Can Do Through the CLI channel. I am Vangelis Prokopiou and you are watching Git Atomic Commits. I wanted to talk about this concept a little bit, about the concept of atomic commits, and especially in relation to Git, which is a very popular version control system, and it is the version control system that I myself use. So today we will see two things. The first one is what an atomic commit is, and the second one is how we can achieve that, what workflow can we use in order to achieve having atomic commits in our code bases. I will show you how I do it, what is my workflow, and of course you can comment in the video about what you do about this matter. So let's start this video by checking out this Wikipedia page about atomic commits. There is an article called Atomic Commit, and I would like to read with you the first paragraph, which is, let's say, the definition of an atomic commit. It says that in the field of computer science, an atomic commit is an operation that applies a set of distinct changes as a single operation. If the changes are applied, then the atomic commit is said to have succeeded. If there is a failure before the atomic commit can be completed, then all of the changes completed in the atomic commit are reversed. This one is mostly related to the database systems with atomic operations and not so much to the version control system. Let's continue. This ensures that the system is always left in a consistent state. The other key property of isolation comes from their nature as atomic operations. Isolation ensures that only one atomic commit is processed at a time. The most common uses of atomic commits are in database systems and version control systems. This is, let's say, the official definition by Wikipedia, and we will try to make it a little simpler, and I would like to define it as an atomic commit is a complete set of functionality. When we make an atomic commit in our repository, we add to the existing code base a set of complete functionalities. The atomic commit is not does not affect only one file. It may affect one file, but it may affect multiple files. But the fundamental point here, the fundamental idea is that the atomic commit adds a complete set of functionality to our program, and if we revert this atomic commit, the state of our program reverts back to the last working state. This is, let's say, the abstract definition of an atomic commit, and now we will write some code in order to be able to understand it a little better, and in order for me to show you my workflow regarding the atomic commits. So let's come here and let's pretend that we have a spec, and our spec is to create a calculator class in order to be able to calculate in our program. So we will start implementing this, but before we do this, we will come to our terminal here. Let's go to our terminal. This is the new line. Let me zoom in. As you can see, I currently have only one branch, the master branch. So since we are starting working on a new feature, I always create a new branch. So we will create a new one. We will say git checkout b. I always precede the name with feature / and then I give a name to the feature, in this case calculator. This is what I do, but also I create another branch which I always give the same name plus the dirty extension. So if we see our branches, we will see that we have the master, we have the feature calculator branch, and we also have the feature calculator dirty. Now, why do I do this? The concept is that I do all the dirty work here, all the development, and when I have something that can be committed atomically, then I commit from this dirty branch to the feature branch. You will see it as we progress with this, but this is the concept that I follow. So we are on the dirty branch here, so we will start implementing this feature, and we will start by creating a calculator class. Okay, and we will start implementing the methods. So the first one that we want is an add method, which will accept two arguments, number 1 and number 2, and what it will do is return n1 plus n2. We are ready now to create a commit. We have made some progress, so we come here and we say git add all, git commit, creating calculator and add method. So I just created a commit in the feature calculator dirty branch. This commit may seem quite clean and atomic, and it is to an extent, but we are just emulating now a real world project, and in a real world project there may be times that you have to commit code that maybe it is not in a working state, or it is not finished. You have made some progress and you want to commit, but of course it is not finished. This is the usage of the dirty branch. In this branch I always have the ability and the flexibility to make such dirty commits, and you will see such commits while we progress. So we come here and we continue our project, and we want to implement our second method, which is to subtract. We want to be able to subtract, and this method returns n1 minus n2. Now we reached another point. We have made enough progress where we can commit, and now imagine that our progress is not so small like in this case that we had to implement the subtract method, but imagine that it is quite complex and involves many stuff, and we are implementing a method that it is not yet ready. So we have the ability on the dirty branch to say git add all, and we will git commit, and we can say progress with the subtract method. Let's pretend that the subtract method is not complete yet, and this is a quite good commit for this use case since we are on a dirty branch. So I commit and have a new commit, progress with the subtract method. Not subtract, subtract anyway. Let's continue working, and now we have to implement the multiply method. multiply, which will return n1 multiplied by n2. So we can also commit here. And we can say many times, I will show you what I do. Many times my commit is so bad because I don't have something solid as a commit message, because I haven't created something solid enough, and maybe just progress with calculator. This is a very dirty commit, of course. Progress with calculator, as you can see, this is very generic commit message, a very bad commit message, but since we are on the dirty branch, I don't care. I just want to commit the work that I have done so far. So I continue here, and I have to implement the divide method, which will return n1 divided by n2. So we can come here and we can say git commit calculator methods implemented. But of course my feature is not ready yet. I have to test it, and of course we should create unit tests for testing, but in this case for the video we will create just some console logs in order to check our functionality. So we will say that we will create two calculators, calculator 1 equals new calculator. This is our first calculator, and we will create a second one, and now we will console log calculator 1 dot add 1, 2, and our second console log statement would be calculator 2, and we will say subtract 10 and 5. And let's do a third one just for fun, and we will say here multiply. Ωραία, nice. And since we did the work so far, let's create the fourth one and use the divide method to be complete. Divide, multiply and divide. Okay, let's go to our terminal and let's run our program. We see that it is working, and if these were unit tests and were green, we know that everything looks good. For now we will check it ourselves. The first one, add 1 and 2, we should expect 3. Indeed we have 3. Subtract 5 from 10, 5, that's right. Multiply 10 with 5, 50, it's correct. And divide 10 divided by 5, the result is 2. Everything seems good. So we have new code here. We have the tests, let's say, so we will say git add all, git commit adding tests. Now we have all these dirty commits, as you can see here in our dirty branch. We have all these which are dirty commits. Now what I do, because now I'm sure that my feature is ready, it's complete and it's tested, and I know that I can commit it in an atomic manner. So how do I create this atomic commit? I create it by merging this dirty branch to the feature calculator branch with squash. So we will do this. Here we change to the feature calculator, and what I will do is git merge squash feature calculator dirty. This will bring all the code, all the progress from the dirty branch, but it will not bring the commit messages. It will just bring the code and have all the files staged. So let's run this command. You see updating, fast forward, etc., etc., squash commit not updated head, and if we check our status, we have the index.js staged, ready for committing. So we can come here and say adding the calculator class with tests, let's say. Now we are on our feature calculator branch, and if we check our logs, you will see that we have only one more commits from the master. Our difference from master is this commit, which includes all the commits from the dirty branch, but they are squashed to one descriptive and atomic commit. It is atomic because if we revert this commit, then the code base and the functionality will revert back to the last working state, which was, in this case, adding index.js. Now, I'm repeating, the way to create this atomic commit is to check out to your feature branch. This is our feature branch in this case, and to merge all the dirty commits and all your projects from this dirty branch, merge it into your feature branch by squashing. This creates this atomic, descriptive and clean commit in the repository. Now, this code, this commit message, is very easy to merge to master or to do it whatever else we want to do it, and I will show you what I mean by that. Now, let's say that we are ready to merge to master, but before merging to master, let's check out master. Now we are on the master branch. Before we merge that functionality, let's create develop. We created a develop branch, and let's say that we also have a feature 2, let's say. The calculator was feature 1, and we also have another feature under works, which is feature 2. So all our branches now are the master, the develop, our calculator feature, the dirty one and the clean one, and we also have a feature to branch. Now, as we said, we have created this atomic commit which exists in this feature branch, and we want to send it to master. We can do it either by merging this feature branch or by cherry picking this commit, because it is atomic and it is very easy to cherry pick it and take it and bring it to whatever branch we want. We will do both of these things. We will first check out the develop branch, because this is how I set up my repositories, and we will use the first method, which is bring this functionality through a merge. So we will say git merge this feature branch, and since this is very clean, the merge will be executed, and we just fast forward. If we see now our commits at develop, you see that we got all the functionality that was on the feature calculator branch. And now we can also get it to master by merging the develop branch. But as we said, we may want to take this functionality and take it to another branch which is under development. Let's say that this branch is merged to master as it is, and we now continue work to the feature2 branch. But since this functionality is now merged to master, we want to take it, and it is as easy to take it as cherry picking it. Instead of merging all of master to this feature branch, we can just cherry pick this commit. And how will we do it? We will git log master first. We will see this hash. This is the commit. One commit is a single feature. This is the commit that we want from master, and we will say git cherry pick this commit, and this will bring this whole functionality to this feature2 branch with cherry picking. So we will run this command, and you will see that everything went well. And now in this feature2 branch we also have the calculator, and if we check our code, you will see that this is the calculator as we developed it. This is mostly what I wanted to show you in this video. I hope that it was quite informative, because it is a very important concept, the concept of atomic commits, because if you create atomic commits, then your repository and the code base is a lot more manageable and a lot more easy to cherry pick functionality from branch to branch according to the development status of each branch of each feature. So I repeat, I hope that this video was quite informative and will help you in the future with your version control workflow. This is what I wanted to share with you. If you indeed like this video, you can help spreading it by sharing the video. You can also comment, like and subscribe by clicking the penguin that you will see on your screen. Thank you for watching and have a great day.